right, here we go. We have this equation and we want to find a general solution. So what we're going to do is put the x's together on one side and the y's on the other side. Now if we want to find a general solution, we need to take integrals. So we're going to take the integral, and when we do, we get negative y squared over 2. Now this is two different constants. We don't know what they are. Let's put the constants all on one side and just call it a big C. Now, how do I get rid of the 2? Multiply everything by 2. So now I get x squared plus y squared equals even a bigger C. I doubled it. I don't know what it is. It's just a constant. Does anybody recognize what shape that is?
Circle.
It's a circle.
It's a circle.
Okay. All right, so let's try the next one. Find the general solution, and they gave us the derivative this way, and then find a particular one where the point lies on the curve. So the first thing I'm going to do is I'm going to write f prime x as dy dx. And now we want to put the y's together and the x's together. Once we do that, then we're ready to do what? Integrate. So now we're going to integrate this. Now remember, this is y to the negative 2. The integrations aren't too bad. So when I integrate this, I get a negative y to the negative 1 equals 4x cubed over 3 plus my c. So now I'm going to come up here, and I have negative 1 over y equals 4x cubed over 3 plus c. So I'm going to multiply everything by what? I want to solve for y. Well, let's first multiply everything by y.
That works.
So now I've got 4x cubed over 3 times y plus y times whatever my constant is. I'm going to factor out the y.
Can you just get that stuff?
All right, guys, welcome back. We made a mistake with our fractions, and so what we're going to do is go through the process. C is just a constant, it's not a variable. And so once we factor it out, then we get a common denominator. 3 times whatever that constant is. We don't know if it's positive or negative. It's just a different constant. Now you could use different letters if that helps to clarify it. And then we solve for y. And then we plug in our specific point 1, negative 1, and we got negative 1 equals c. So here is our general solution. Where did it go? Right here. This is our general solution. And our specific solution is now, and this is our, they call it a particular solution. Okay? Does that make sense? So here we have this differential equation, and y is a function of x, and y is always positive. So what we're going to do is rewrite it as dy dx equals ky. We're going to put the y's together. Do you see this as a huge algebra kind of issue before you actually get to calculus?
Yes.
Then we take integrals, and now, what's the integral of 1 over y? ln y equals k x plus c. Now how do I get rid of this natural log?
Thank you. No.
Take the derivative.
How about exponentiate?
Oh yeah.
So now this gets to be y equals e to the kx times e to the c. E is a constant. Raised to a constant. Right?
Right.
So if I have this, I've got e to the kx. This is just a constant. Could I just call it a?
Sure.
Why not? Now here's my equation. Okay? Stay away from X, Y, and Z because those tend to be variables. And if you stick to capital A, B, C, those tend to be constants. All right?
Right.
Any questions on this part? All right, let's do